This is Tube, and this is the bottom or lower motor shaft bearing on a Singer PA style motor. This particular one happens to be out of a 301A motor, and it's sometimes called the bottom bearing. I think technically they call it the motor shaft bearing armature end, meaning like armature end, and the bearing goes like that. And I wanted to do a video about this for quite a while, going back a couple years actually, when I had a comment on a video by G Russo about this type of bearing, and I've communicated with him frequently since then, and I finally decided to do a little video about it. And the first thing that I want to do here, because I know that a lot of viewers are in a hurry, if you can see the bearing, this is a 401A motor here that I have disassembled, and if you can see the bearing down in there, and it's held in place with this bearing spring clip, and this pushes down on the bearing, holds it in place, and these springs flatten out, they flex down and flatten out, and they go in a little area I'm going to call a clip that has kind of a, I don't know how, maybe like a C shape something, and the clip comes in and the spring pushes up and gets caught here. And that's what holds it in there. Well, there's a little bit better light on it. Okay, so if you get to this point and you in your disassembly and you want to get that out, there's a few ways to do it. If you text a lot on your smartphone, you may have the thumb strength to remove it. Basically, what you're going to do is push down on the sides of those springs and flatten them out to get them below the top of that C-clip, and then rotate the spring just not even a quarter of an inch counterclockwise to remove, and that will pop those springs out of the clips, and then the spring can come off, and then the bearing will often just fall out or maybe tap out. Okay, so let's see, let me see if I can show you how to do that. I wanted to explain it because you can't look, when I get my thumbs in here, you can't really see what's going on, right? Okay, so I'll just put my left thumb between the bearing and that clip towards the tip of the spring, and my right thumb on the other side, and then I've done this where I've just put it flat and pushed down, or squeezed it like this. So for the video I'll try and squeeze it. So I'm pushed down, it's very stiff. Push down and give it a little turn, and I don't know if you could hear that little click, but there's the bearing and there's the spring. See? So here's what it looks like in there, empty. See the little retaining area down there. Okay, and then to put it back in, you just kind of do it in reverse. I'm going to put this barbecue stick down in the retaining area. I found this easier for me just to get the bearing to like line up in the hole down there. And then drop this in and kind of try and drop it in a position, but you usually have to work on it a little bit. Actually, that fell pretty good. And now I'm going to position it so that I can turn it clockwise to the right and get the clips to lock in. So this clip or the spring tip on the left side is below the clip, and on the right side the spring is above the clip. And I'll just try and keep it in that position while I get my thumbs in there, and I kind of twist it without pushing down hard to get it right up against the clip so I don't have to move it far once I push it down. And then I'm just going to really push it down hard and try and twist it. Yeah. Ouch, see that? So let's try it again here. You want to get close to the end of the spring to put the most flex on it when you push down, but I got my finger caught, or my thumb caught between the spring clip, the spring tip and the clip one time, and it wasn't a pleasant experience. So now, it sounded good, right? But I went right over the top of the spring. Ta-da! So another method I found I can only do this a couple times, and my thumbs can't take the pressure anymore. But another way I've done is to tilt the spring so that the left tip is just barely entering the clip area. So instead of being flat, I've got it tilted a little bit with this end entering the clip. Then I can hold it there, so it's kind of like that side of the spring is going to be already flat. See? So now if I can push the other side down flat and close and twist it, then I can get it back in. So that helps me sometimes by getting one end. It doesn't have to be the left, but just getting one end barely entering into the clip. So that end is flat against the base, and you're only holding it there while you're really pushing down on the other side. Okay, so there you go. What if you don't want to do that, or you don't have the strength to do that? Because I took I've only got 3 motors out here, but I took quite a few of these apart to play with these bearings and study them. So I got to where I couldn't do it. My thumbs were too sore. And one more thing. It may help you if you wear some kind of a glove, because the clip is metal, and it's smooth, and then you've got your skin. So if you wear a glove, it may help you get a little bit better grip on that spring. After you push it, you've got to turn it, right? And the glove may help you do that a little bit. So I came up with this little homemade tool that I'm going to call the twist stick. Okay, and here's a slide with the measurements that you can go back and look at in the future if you want. It's basically, I bought a piece of scrap wood 2 feet long, about a 1/2 inch, and they called it a furring strip. And I just went to the Home Depot down the road, and they have scrap lumber where they cut wood to people's measurement, and what's left over they kind of throw in a bin, and you can buy it for 50 cents to $1. And this 2 foot long piece of wood was 50 cents. So I brought it home and I cut this wedge out, and it's an inch and a half. So I started at 1 inch wide and cut a groove in a 1/2 inch deep, which left me a 1/4 inch on each end, and then I kind of filed these off around a little bit, so I wouldn't have sharp, pointed corners that I would get stuck against the clips. Okay, and then as I've used it, I've taken a utility knife, which I thought I had out here. Let me just get a knife, and I've scored, or what else could you call it, scratched the end of those 1/4 inch pieces, because they were, this is kind of a hard wood, so I would cut little X patterns into there just to try and, like, I guess, give it some texture, right? And that lasted for taking out about 10 bearings, and then I had to kind of score it again because it was getting smooth. But the thing with this is you're using this to push on it instead of your thumbs, right? See if I can get it in here, and you're just going to put those 2 1/4 inch pieces, which happen to fit right inside the clips, and you're going to push down on your twist stick to flatten that spring. And then when it's flattened, you give it a little twist, and it'll pop that spring right out. Okay, and then, like I said, this usually will tip out. I had one really dirty motor where it was stuck down in there pretty good. It was a 301, and there was some felt under it, like a oiling felt, so I had to tip it over like that and tap it out, and then it came out. And you can put these in, and kind of twist them around and line them up without using the barbecue stick. I just found it easier with the barbecue stick, but this is going to be the same thing. When I removed it, I'm turning it counterclockwise to get the spring from under those clips. Now I'm going to put it back in there, and by the way, when you put it in, these ends of the springs are pointed up, and that's because the top of the spring has built up a little bit to hold that bearing in place, so it does not go with the springs pointed down like that. Okay. It'll be self-evident when you take a look at it. It's like that, so that the spring can kind of cup the top of the bearing, and that's to keep the bearing from spinning too, because you want the motor shaft to spin, not the bearing, right? You want the bearing to be straight. Okay, so anyway, once you get that bearing and clip back in there, then you can take your twist stick and use it to depress the spring flat and turn it and turn it. There we go. Took me a couple tries, but then the spring is back in there and the bearing's mounted. And if your bearing is a little Like let's say it's pointed off to the side like that. Just using a barbecue stick, or when you put the motor shaft in, it'll be like a self-centering bearing. Okay, so if when you first get it in there, it's not perfectly straight up and down, you know, say it's a little crooked, like over here, over there, you can adjust that a little bit. I mean, just straighten it out. Don't use metal. Don't use a screwdriver. Okay, and when I explain these sintered bearings later, that'll help you understand why. But there's a couple of ways for you people in a hurry. I had tried was a pencil with an eraser, and I could push down on one side. Now this usually has a flying spring, and they can come flying out of there. So you push one side down and you move it over to the edge. I can't do it when holding it. You move it over to the edge of the clip. Look at this poor eraser, so old. It'll help if you have a softer eraser than I have. But I did this a couple times too, just using the pencil to move the one side of the spring over towards the edge of the clip. Just get it under the edge of the clip so it could start to come out. Okay, you can't go very far because the other clip is holding the other end. But once you get one end under, you can other one over, down and over, and that will release the spring. And I don't know if you saw it come flying out of there or heard it bounce on the floor. So, you know, have your safety glasses on and stuff and be careful. So if you don't want to make a twist stick, that's great. I mean, look there, you can just use a pencil. Let me take this other spring, and to get it back in, you're going to kind of do the same thing you did with your thumb. Just push down one side and get it twisted under the edge of that clip. Okay, and then you can just hold it in place with your thumb a little bit. It doesn't take much. Or hold it in the center. And now you're going to push on this clip down and twist it into under the clip. I mean, push on this spring tip and push it down, whoop, down. It works better holding it flat, down and under the tip. I should have looked for I don't have any fresh pencils. I don't use them too much, huh? I was surprised I even found these in a desk drawer. Oh, sorry. I'm probably right in your ear. That chewed up this old dry eraser pretty good, so I was just blowing out the eraser parts. But that got it back in there. So I was able to use a pencil a few times. I tried, before I made my twist stick, was just a paint stir stick, right? And the same kind of principle where you get one side pushed down and over so it's partially coming out of under the clip. And once you've got that, which I haven't done really. Let me try that again here. Once you get just there, see, I've just, well, you can't see. I've got it barely coming out of the clip. Now when I push this other one down and out from the clip counterclockwise, very common the spring can come flying out. Well, the spring bounced up and hit this. So, I wish you could see in there better, but here's the opening on the bottom of the housing where those clips go. I mean, where the spring goes. Let me put one side of this one in there, and you can see. I'll just try and slide it in without the bearing in there, just to get the tip of the spring in place here. Let me give you a picture of that. That'll be better. You know, when I saw this before, I always thought maybe it was for ventilation, but it makes me wonder now if Singer didn't have a little tool that they could use to pop that spring out. I can't imagine somebody putting them in with their thumbs all day. Okay, so there we've got our twist stick, and we've got a pencil, and we've got a paint stirring stick. You know, here's the flat end of the barbecue stick. If you can't get a good grip on the spring, you could put a big rubber band in there and catch the rubber band on top of the spring and use it for a gripper. You could put a finger of a glove down in there and use it to grip. For me, taking the time to make this was the best way to go, you know. So I played around with this over a dozen times so that you wouldn't have to, that you have some idea of how that system works, and how you can get the spring off and get that bearing out if you want to clean it. I can't imagine the bearing ever going bad, really, but if you stick around now for the best parts of the video, you'll learn about the sintered bearing, and maybe a better how to clean it and how to lubricate it. Okay. And then one more thing before I move on, and I'm sorry, in the beginning of this section of the video, I said if you've gotten your motor to this point and you want to remove the bearing, I'm sure there's some people that said, how the heck do you get the motor to this point where you get it all disassembled like this? And at the end of the video and in the description area below the video, I will put a link to a playlist I have of rehabbing the motor, and it shows how to take all this stuff apart. And later in this video, if you're hanging around, I wanted to take apart a 301 to show you the wick I was talking about, and explain about this little crease, this little groove in the side of the bearing. Okay, so if you're taking off now, just look in the description below the video and you can follow the link to a playlist about how to take apart a PA style motor. Alright, this is the 401A motor that I'm going to be working on, and I'm going to be disassembling it and taking out the bearing and checking it and oiling it and so forth. And before I do that, I wanted to do some tests for noise and for heat. So I just have a sound meter app on my phone, and you can see the gauge here, and you can see the reading up here. So right now with just me talking, you see it gets up to into the low 70s sometimes. And then when I'm quiet, it drops down to the 40s. Okay, so I'm just going to hold it here next to the motor, and I'm going to take my dial here and start up the motor and run it for a while. So you see at the peak there it was about 78 or 79. So we have our reading for noise before I do any work on the motor. And next I'm going to let this cool off for a little bit, and then I'm going to come back and try my new infrared thermometer and try and get a heat measurement down here right on the bearing, and kind of do that before and after. Now I've never done this before. I don't know how well it's going to work, but after the motor cools down a little bit, I'll be back and we'll try that. Okay, I'm going to take a reading before I start. I've got almost 81 degrees Fahrenheit. Okay, now that we have a cold motor reading, I'm going to go ahead and run the motor at top speed, and then we're going to take some readings as we go here to see if the temperature changes, and I'm sure it will. So we got up into the 90s and even the mid 90s now running the motor. So there is a fan up in this housing, you know, that blows and circulates air in the motor to try and keep it cool. Pulls air from the side and the bottom here. So with that fan off, I'm expecting the temperature to heat up a little bit, but let's see. Yeah, now I have over 100. So that's what I would expect. The cold motor temperature should be about room temperature, and then running it got up into the 90s, mid 90s, and then now that it stopped running, the heat that's been generated, there's no fan, it got up over 100, 101, there's almost 104, you know. So that's what I was hoping to do, was document this, and then we're going to take the motor apart and take a look at the bearing and oil it the way G Russo explained how to do it. And then we're going to reassemble the motor, and we'll do the sound and the temperature readings again to see if it made any difference. Okay, I'm going to just do a quick disassembly of this 401A motor for those of you that have never done this. Those that you have, you can look in the timeline below the video and skip on to the next section. But you're going to start this with removing the brush covers. It's a little bit of a triangular shape Bakelite cover held by one screw. there's two of them. They oppose each other, and just there we go. Oh, what happened to the screw? Oh, it fell into the motor. There we go. Just a short screw like that. Here's a look at the brush cover. And then inside you can see the motor brush holder, this brass kind of square tube, and you can see the contact spring, and the hex nut that holds the screw I just took out. And at this time I go ahead and take out the motor brushes so I can get them out of there. And up here, the way I do that is I'm just going to tilt up the back end of that tube a little bit like that so that I can get a hold of it, and I'm slow. It's held in there by that contact spring, and I'm just going to pull it out slowly so this brush doesn't come flying out because it's pushed against the motor by a little spring. Okay, so here's the motor brush and the motor brush spring and the motor brush holder. Okay, and then you do the same thing on the other brush cap. Take out the screw and the brush cap. We'll see the same thing on this side, the other motor brush and the spring contact and the hex nut, and we'll just tilt that forward a little bit, grab a hold of it, and slowly pull it away, bringing the brush spring with it. Okay, now what's holding this top part of the motor housing to the bottom part is a couple of long screws right here and here, and they go into the other end of those hex nuts. Okay, so we'll just remove those so that we can separate the motor housing. Here it comes. This is a long screw. And then we might as well remove that hex nut now. It's just threaded all the way through. So the long screw goes in one end and the brush cover screw goes in the other. And let's turn this over and we'll do the other one. So the top part of the motor housing is made from cast aluminum, and the bottom part, the black part here, is a type of Bakelite plastic. Get that out. The other hex nut. So we're going to start pulling these apart now. Okay. And up in here, there's a couple things you got to watch for, a couple small parts. So just wiggle those apart. And here's one thing we're looking for. This is called the wedge. It's a little bent piece of metal that slides into a space in the housing up here, and then the other end slides into a space here on the bottom cover. So you see I pulled this off now. Let's see, I put this aside. Now there's a part missing in this motor, and that's a little piece of a fiber board that sits here and presses up against here, and that is an insulator between the contact pins and the motor housing, and that is gone. Okay, you never know. Oh, no, it's not here. It just stuck and then it fell off. There we go. See, it's just, it's like a piece of chipboard or press board. And you'll see when I put it back together, but it fits in here and it presses up against here when you slide this back together. Okay? Couple things that you saw how easily I lost that. So a lot of times what people lose is this little clip, so be sure to hang on to those. Now by pulling this off while holding this part of the motor, the spring clips and the contact pins came out of the housing. So this is the bottom of the housing here. And you can see down in there, I hope, the bearing and the retainer, bearing retainer. So if you want to continue to pull this off, you can, if you want to do a little cleaning or anything like that. And here you see the commutator, and up in here you'll see the fan. A little metal fan in there, and you'll see a insulator. This is kind of a delicate plastic now because it's old and it can crack pretty easy, and don't be surprised if you pull it out and it has some cracks in it. So just be careful with this. It is delicate. Treat it kind of like an eggshell. Okay. Yep. Okay. So we're concerned with this part of the motor, since this is a video about the bearing. So now that you know how to get access to it, I'm going to show you some ways to clean it. Okay? Okay, I decided at this point to talk a little bit about the bearing. So here is another bearing. It's the same as type as the one in this motor that I'm working on. But what brought about this video I'm doing right now was a comment that G Russo made on one of my videos about 2 years ago. Now, you saw at the beginning of this video, I thanked G Russo of American Sewing Machine Restoration for sharing his knowledge and expertise. And he did. He helped educate me about these. And as somebody that puts on videos like I do, I try and get good information, informed information, and accurate. You know, a lot of it's my opinion and my experience, but I really didn't know anything about these little bronze bearing. So his comment a couple years ago was on a 301A motor video I made, and he explained that these are a powdered bronze metal bearing, and they're made by mixing metal powers together and compressing it. And then they sinter it in a furnace. They heat it up. Now, you can Google sintering process, and it's quite fascinating. But my understanding is it heats it enough to molecularly bond the powdered metal blend together so that it's hard like this, but it doesn't liquefy it. And that process leaves these little microscopic spaces or voids in the metal. And that is what holds the oil. Now these are often called oilless bearings, but they have oil. Now I give you a little history about John and why I appreciate his educating me on this, and why I think he's very qualified to speak about it. He has an Associate of Science degree in Manufacturing Engineering from the Thames Valley State Technical College in Connecticut. And right out of college, he was recruited by the Pitney Bowes Company. And he started working for them about 2 weeks after graduation. And he worked there for the next 31 years. And they had a very large powdered metal department at Pitney Bowes. And that's how he became so familiar with powdered metal process. So that's good for me, and that's good for you if you want to learn about these. So about a year after John left his first comment, another viewer named Daryl Youngman commented that he agreed completely with John and his comment, and that he worked with these oilless, quote-unquote, powdered metal bearings at the Sangamo Electric many years ago. And as soon as he saw the bearing in the 301 video, he knew exactly what it was. So about a month ago, a longtime viewer, Carol Magnuson, commented on that same video, and that she had had a noisy 404 model 404 motor that's just like this, and it was making kind of like a growling noise. So she put a couple drops of 30 weight motor oil up here, but that didn't help. And she put in new carbons, and she used the brush seating stone. She put in new carbon brushes and used the brush seating stone, like in my video, to make great contact, but that still didn't help. She came across this old 301 video I made, and she read John's comment. So she took the brush caps off the bottom of the motor, and looking in there, she could see this little groove. So she didn't take the motor apart like this. She took it out of the machine, removed the brush caps, and when she saw this, she used a toothpick to just drop some tiny drops of oil down into that groove. Okay? And put everything back together and fired up the motor, and the noise was gone, completely gone. So that was the, third time's the charm. That was the third thing about bronze bearings that encouraged me. Man, I have to learn more about these, and that's when I really started contacting John more frequently. We had been in contact over those 2 years, on and off, but I asked him, hey, tell me more about these, and so forth. And his comment in the beginning was about how the oil in this bearing, when the bearing heats up, it's drawn towards the surface and it lubricates the shaft, and it creates a thin film of oil for that shaft to spin, and it keeps it lubricated. When you shut off the motor and the motor cools down, that oil is drawn back into the bearing. Okay? And I had, on the advice of a couple other people, had put a small amount of tri-flow grease into the bearing, thinking every time I saw it, I didn't see any lubrication, so I didn't think it needed any. But then a couple people advised me that they put a tiny bit of grease in there and it helped. So I did that. I didn't notice much difference. But what he's talking about is when you take it apart, you don't need to clean it with alcohol or anything like that, because you might pull some of the oil out. What he talked about was just putting a little oil on a Q-tip and wiping out the inside of the bearing. And the thing with this is you could do this without taking the bearing out. And he said, just you have the motor shaft out, so you just wipe it with this to be sure that if there's any debris or anything in there, you can do that. Any residue that's in there, and it will help it soak up some oil. So you see there's a very slight discoloration on there, and he felt if you got too much oil on there, you know, you could use a dry end of the Q-tip to just kind of swab out any excess. But this would help the bearing soak up some of the oil. And you know, they call it oilless, but like he said, hey, these things are 50 years old. That oil couldn't have lasted forever, you know. So he felt that that was a good way to go. Now, I have cleaned pieces like this with my crud cutter and alcohol and stuff like that to clean out dirt and so forth inside the motor. And personally, I still think I would do that, but I would have a whole different attitude about treating that bearing now. So at the least, I would put oil on the Q-tip and go in and swab out and clean as much as I could, and then help get fresh oil into the bearing. One of the articles I read about sintered bearings from a manufacturer of the bearings was that they can hold up to about 20% of their weight of oil. And the way John said that they originally prime these with oil will be to put the sintered bronze parts in kind of a basket and put them in a like a vacuum chamber with oil to help draw the oil into the bearing. That was how they originally were like loaded. So if you are cleaning the motor and you don't want to take out the bearing and the retainer, try wiping it out with fresh oil and see if that helps you. And like Carol Magnuson said, she just went in from the side and got a few tiny drops of oil into that groove to get it down in under the retainer and onto the bearing, and that helped eliminate this growling noise. So that's a little bit more about bearings. And as far as oil, I questioned John about a Tri-Flow, and even though I love Tri-Flow oil, I was concerned that this additive PTFE in Tri-Flow oil, it's like a type of Teflon that's supposed to help reduce wear. But I don't, you know, I wondered, is that going to get stuck in these microscopic voids? I don't know much about it, and I was a little concerned, and I mentioned that to John, and he agreed, you know, hey, maybe that's a possibility. So we're both of the opinion just to use regular sewing machine oil. And John's good point was the motors have worked well for 50 years with just regular sewing machine oil. So, you know, if we refresh them with sewing machine oil, maybe they can go another 50 years and we don't have to worry about any Teflon deposits, PTFE deposits in there. So that would be my advice, is just to use regular sewing machine oil. Okay. So if you're at this point and you want to remove the bearing, and I did because I wanted to experiment with it more, you can use one of the methods like the twist sticks that I developed. But this is why it's always a good thing to watch my entire video and not be in a hurry, was because I asked John to review the first part of this video where I talked about removing the bearing. And he liked the video and stuff, but he made a great suggestion, and it's the difference between a hobbyist and my idea for getting the bearing out, and an engineer and his idea for getting the bearing out. And what he suggested was to take a wooden dowel and drill a hole in the bottom so that it could fit over the bearing, like I drilled this triangle opening. A round wooden dowel on this, if I twisting and it slips, it could come right off of that retainer, where this, as it turned, would just have some surface on the retainer. So maybe a better grip and less likely to slip off. So, thank you so much, John. I went down to the hardware store and I bought a 2-foot dowel, and I cut off about 10 inches of it here, and I drilled a 3/4 inch hole. Now this is a 1 1/8 inch diameter, where this is 1 1/2. And I tried it before I put this motor back together, and it worked well. So no matter what method you use, a twist stick, or if you want to make a dowel remover, or I had my paint stick and I even had a pencil with an eraser, you go ahead and take out that bearing retainer and bearing. Tight fit, huh? Okay. Now, if you wanted to do that first, then you could clean this Bakelite part with the crud cutter cleaner and degreaser, or dish soap, or alcohol, or whatever you want, if you have a greasy, grimy motor base here. And you could do that like this without getting any type of cleaner onto the bearing. Okay? So this is how you disassemble the motor. That's a little bit about the bearing itself and how it's made, and how it's recommended just to swab it out with a Q-tip with some oil, clean any debris in there, and put a little fresh oil and let it soak in. So here was part of my experimentation with this bronze bearing from a 401 motor. Okay, I wiped it off just with some Q-tips and a rag. It didn't seem very oily to me at all. I put it on a paper towel and left it there for 24 hours, and it did not leave any oil residue. So I put it in a basket and I heated it with a hair dryer, very hot, as hot as I could get it with just a hair dryer, and it was way too hot to handle. So I dumped it out onto a paper towel and I set it like that, you know, the way it sits in the motor for 12 hours, and then I turned it on its side for 12 hours, and I had barely, when it was like this, I barely had some tiny bit of oil, about a half a circle, a little tiny bit of oil. So I don't think this originally had much oil left in it before I ever got my hands on it. So I heated it back up and put it in a cup like this, and I covered it over with alcohol, and I let it sit in the alcohol overnight. And my idea was heating it up. As it cools down, it may pull in some of the alcohol the same way it pulled in oil. And I wanted to see if I could remove oil, if I could get rid of oil from it and make it kind of a dry bearing. Okay, so that was my purpose of doing the alcohol thing. It off again with water, and then I put it in a glass container and I poured boiling water on it, trying to drive out any alcohol or cleaner that I may have had left in there, and finally blew it dry with the hair dryer. So that's where this is right now, and that's what was in the motor when you heard me do the motor sound and heat test. Was what I feel is a pretty dry bearing. I wanted to see, and maybe you kind of heard a whining type of sound, and that sound has kind of been common to motors of this type I've worked on, and now I'm wondering, are they just dry? Do they just need a couple drops of oil to recharge the bearing and create that little film of oil for the shaft to spin on? So that's my plan with this, is I'm going to heat this up with the hair dryer again, and then since I'm getting low on oil, I'm going to use a smaller cup. But when it's hot like that, I'm going to put it in this cup, and then I'm going to cover it with sewing machine oil and let it sit for many hours. I don't have a vacuum chamber, I don't have anything like that, but I'm hoping that as it cools down and soaking in that oil, it can pull some of that oil in there. And that's my plan for this. So I'm going to heat it up, put it in here, cover it with oil, and then let it sit. And while that's sitting, I'm going to show you how to take apart a 301A motor and the little bit of differences down in the bearing area of that, if you care to see that. Okay, and then once I recharge the bearing, or hopefully recharge it with oil, I'm going to reassemble the 401 motor, and I'm going to redo the sound and the heat test to see if there's any differences. So if you'd like to come along for that ride, you know, you can look again at the timeline below the video and skip to any part of the video that you're interested in. Okay, as I planned, I heated up this bearing from the 401 motor with a hair dryer, and I've dropped it into a small cup of sewing machine oil to give it a long bath, in the hopes that it pulls in the oil into those microscopic spaces in the bearing. So put that aside for a nice long soak, and while I'm doing that, if you'd care to watch, I'm going to partially dismantle this the 301 motor and show you some things about it, because it has a couple different features than the 401, 403, 404, 500A, 503A type motors. As far as I know, this was the first PA style internal direct drive motor that Singer made, and they came out with the model 301, a quite revolutionary machine. One of the things that's a little different about this first PA motor was this silver tube here, and I've always called it just the silver lube tube. Singer's instructions were to squirt a little bit of motor lubrication, the product that they sold, motor lube. Now, over the years, I've had people tell me that they substitute Vaseline for motor lube, and I've did that on a couple of the machines, but I've come to believe that is not a good idea. And if I have a motor I want to lubricate, like recently my 221K series that I did, I buy a product, motor lube, from the Featherweight shop. It's a modern formula, and they have some great videos on there showing you how that does melt and liquefy, which was the theory behind this, was you put some of this motor lube in there, and as the motor heated up, it liquefied and went down and lubricated the bearing, which could lubricate the shaft. So I'm going to open this up and show you a little bit about the inside. Mostly everything you see is going to be the same as the first motor I showed you. But there are some differences, and the first is that tube. I used to think there was a wick in there, but I have never seen a wick inside this particular model of motor. So it's going to dismantle. You take it apart the same way that I've showed before. I like to take off the brush caps, and it's a little trickier with this motor tube lube tube in there, so you kind of have to lift it up and out, but it's the same principle. You'll see the same parts inside there. You'll see the little spring in there. You'll see the housing for the motor brush, and down there you'll see the commutator, and down at the bottom is the bearing with a bearing retainer, just like in the 401 motor. Okay, so while I have that open, I'm going to do the same thing. I'm going to tilt this out a little bit so I can grip it and slowly pull it off, so I can get the motor brush with the spring out. Okay, and then let's flip it over to the other side here, and I'll take off the other motor brush. I remember the 301 I worked on, opened up, was a machine my wife bought, and I was quite fascinated with it, because I said, "Where's the motor?" And it's inside the upright. This side is the same, so I'll just tilt out that brush holder. hold on to it, the spring popped the cover, the holder, right off, but I managed to capture the brush. So I'll pick that up in a little bit. You see the same hex nut, double-ended hex nut in there. So we can turn the motor around and take out that long screw. One of the things I wanted to show you in this video also was taking it apart without pulling out the spring clips in there, the wire clips that carry the electricity and hold the brush tube and motor brush in. So if you don't care to take that disassembly quite as far as I did in the other video, I'm going to show you a little bit easier way that you can expose the bearing and bearing retainer and kind of slide off the bottom cover of the motor. Okay, now we should be able to pull this apart just as I did in the other, but what I want to do is hold on to this part of the motor. See this ventilation area here? So I'm going to grip this one side with a couple fingers and this side with my thumb and pull it this way. Yeah, that's what I want to do. I want to take all those parts off with the base. I almost did it backwards. Get rid of the tape there. Hey, okay, there it came. So you see what popped out, if you remember, was the little wedge clip and the insulator that covers the back of the pins. This one is a little thicker in this first model of PA, and it has a couple of tabs that come down and cover the wires, help hold the wires in there, like that. Where later they just went to a little bit lighter insulator without those tabs. Okay, one of the hex nuts came out. Oh, they both did. So I've gathered up all those little parts so I won't lose them. And now down in here I can see, you can't probably, I can see the motor bearing and the retainer. And I can see over on the right side the silver tube coming through the bakelite. Let me show you a picture of that. Now, if this is all you want to do to get access, good access to that bearing, then you do not have to separate these parts. When you separate these two parts, these little wire springs that have a wire soldered to them and pick up the electricity from the brushes to run the motor, those have to be come out and wiggled through to separate these two pieces. But if you leave them in, you don't have to remove those, which also means you don't have to weave the wires back into this base and put those parts back in when you reassemble. So you can see here the tube and the top side of the bearing and the bearing retainer here. Now what's different about some of these 301 motors is, here's another thing, there's no insulator, there's no plastic insulator like on the 401. And I have never seen one on a 301 motor. So as far as I know, they didn't use it yet. That came when they did the 401, the next generation of this motor. Okay, so if you have one, it's rare because I've never seen one. If you don't have one, that's what I've normally found. I've never found one. So don't be worried about that. Okay, but the purpose of this was to show you if you wanted to go this far and then clean and oil your bearing from here. Be interesting. I'm just going to go down in there with a dry Q-tip and swab it around and poke into that felt I see on the bottom to see if I pick up any. That's dry as a bone. I don't have any debris or smudge or black gunk, at least. Okay, it's a little tight fit in there. Oh, let me show you this. Look at this. Let me get it up here so you can see it better. This is the extended reach Q-tip holder. And you know how you can buy some of these Q-tips that have a hollow plastic tube on them, and then you cut them in half and you slip them on this, and then go back down. Look how easy now I can reach into this hard to reach place. See that? So this was invented by the famous inventing team of Carol and Roger Magnuson. And they sent me a couple of these because they were having trouble getting up into some areas of sewing machines where they wanted to clean or get some oil, and so they came up with this, and it's a bicycle spoke. Just picked up some old bicycle wheel and spokes at I think just a thrift shop, and this end is kind of nice because it's got more of a hook. You can hook springs and pull springs and so forth, and then this end I think he just cut the tip off and smoothed it out to do this. So as I said in here, I didn't see anything, gunk or anything. So if you wanted to wipe some oil on the inside, I think we could put some oil on a Q-tip, saturate that with a few drops there. And then we could go down in there and swab that all around on the inside of that bearing. Okay. So now if you had an extended way, or you're a very good shot, you could maybe drop a drop of oil right onto that pad. But one thing is that the groove in the bearing lines right up with that silver tube. It's turned so the silver tube feeds into the groove on the side of the bearing. And I think when you would put lube in here and it would heat up and melt, it would go down that groove and end up some absorbing into the bearing and some going to the bottom felt pad, which could then be pulled up into the bearing. So it's still a bronze sintered bearing. So at that point, if you're clean and good, you could take oil like in a little syringe, in my opinion, instead of the motor lube. The lube greases, to me, are oil with some kind of a thickener, like a wax or something like that. And that's why at certain temperatures that thickener liquefies and lets the oil spread. So I don't have a problem, I think, on my wife's machine or ones that I would service, of putting a couple drops of oil into this silver tube to let it run down the groove of the bearing and get into that felt pad on the bottom. And I know about oil and commutators, but I did a video where I put 50 drops of oil all over the commutator while it was running, and it did slow the motor down and so forth. But I'm not saying to put that much oil that it's going to come flying out of that felt pad on the bottom and get all over you know, the inside of the motor. Now I bought years ago, I bought a box of 10 blunt tip syringes on Amazon, and they came in all different sizes of syringes, okay, and they came with a bag of different size of tips, and I used them for things around the house and so forth. So I just took a real small one with a narrow tip, and I pulled up a few drops of oil into it here, and I'll show you if I squeeze it a little bit. I'm hoping you can see a drop of oil come out there. Yeah, see that? Not much oil, right? So I'm not going to do it yet, but I think you can do this, and I think you could just turn the machine on its back, take the bottom cover off of your 301, don't do anything with the motor, and just put 2 or 3 drops of oil into that silver tube. Now you may have, your tube may be full of old gunky dried up grease, I don't know. That's why you may want to take it apart, and you may want to take the bearing out and take a look at it and the felt pad, and maybe clean the felt pad and start over. But if you have a growling motor the way Carol did, and she snuck in here and put with a toothpick and dripped little drops of oil into the groove of the bearing, and that quieted her machine right down, her motor, her 404 motor, right down. So there. So you can take it apart this far if you want and just swab out the bearing and see if it's clean and check it out that way, or you could just not disassemble the motor at all and add a little oil. Or I'm going to go ahead and, without separating these parts, because of the new extraction tool that G Russo told me to try, this 1 1/8 is narrower than the 1 1/2 twist stick that I made, and it will fit. See this, I could get it in there barely, but I couldn't turn it to remove the retainer. But because this is round and a smaller circumference, look, I can get it down in there. So I'm going to hold it there, and I'm going to push it down firmly to flatten that retainer and turn it and see if that did it. I'm having trouble seeing in here myself. That didn't get it out of the clips. Let's try again. Can't tell. There, that got it out. I just had to push down a little more firmly while I was turning. I think I let up a little when I was turning. So let's see what happens here. Okay, here comes the 301 bearing, and there is the retaining clip, and I still Didn't get the darn it. I was hoping that felt pad would come out. Oh, it is a little loose. Let's try it again. There it is. Hey. Okay. How do you like that? So these parts you're familiar with by now, but this is just like a little felt circle. I don't know, maybe 1/8 of an inch thick, and it's very dense. It's very high quality, maybe wool. It's very dense. It doesn't flex much. Let's see if I put it on this oil rag and squeeze it to death, if I can get any oil or anything to come out. A little bit. See the spots? A little bit. So we could clean this in alcohol if we wanted. We could wipe this out and oil it, or clean it if you wanted to. Let's see, what have I got here? I think I want to get that, see if I can get that pad a little clean. I mean, there's really no oil in here to speak of. So, and there wasn't any Singer motor lube or anything. So, I'm just going to take a little alcohol and put that in there. Okay, if I'm getting anybody upset, don't watch. And then I'm going to come onto my rag here and try and press that out. Look, nothing came out but the alcohol. So this really was pretty dry. I thought maybe some more oil would be forced out and I could see some more coming out, but evidently not. Okay, so I'll let that dry for a while. I was pleased that I could get that out, and since I've got it out, I'm going to put another tip on here on my Q-tip extender. And I'm going to dip it in my leftover alcohol, and I'm just going to go down into that very bottom space and around it that holds the bearing. So down at the bottom where that see, not much, even around the edges and stuff. Okay, so that's great. Might as well wipe this off too. Now, John had suggested to me about heating the bearing and putting it on a paper towel, to draw the oil out, and kind of weighing it before and after. I had trouble finding a scale I could afford that could weigh this light. And I did borrow one from somebody that's supposed to weigh in grams, and it wouldn't weigh this, and then I would put something else and it would say, okay, that weighs so many grams, and then I would add this, but it still didn't seem accurate. So I put this on a towel cold, I told you the other one, and overnight, and it didn't leach any oil. I heated it up as much as I could and put it on a paper towel, and had a little tiny oil stain. You kind of had to hold to the light just right to see it. So just wipe this off on the outside. Okay, so now can we put it all back together, if you'd care to see me put it all back together. Sorry, I'm showing you the pictures because I just can't get much light down in there, as you can imagine. I want to get that felt back in and secure. Probably should have put a little oil on it now that I think about it. So I've got that back in, and then I'm going to take my bearing retainer, and so pretty narrow fit when you leave this part of the motor in there. Get that in, and I want to see if I can line it up, turn it so that it's close to the clips. Yeah, I kind of knocked it right out. All this fiddling around, maybe it would have been easier just to take these two apart like I did on the 401. I'll be showing you how to put this motor back together too, by the way. But I thought if we didn't have to do all this, it might be easier. And so far it's been okay. And I like that the Russo the Russo style bearing remover fit into this narrow space. I like that a lot because I thought it would save some time if you wanted to remove just the bearing. But look, this is now my bearings come out. Okay, I actually got it lined up, and what I did was not use my guide stick, and I kind of held it up here and dropped it. When I tilted it towards me, I could, let me hold it here so it doesn't come off. I could see light through the opening at the bottom, and then I could use the stick to just move the tip up close to the clip area. So now I'm hoping I can just go in and push this down firmly, a lot firmer than you think, and give it about a 1/4 inch twist or so, and lock that retainer into the clips. Ah, that worked. Wow. Thanks again, John. That's a great idea. Worked very well. So now we're back assembled that part. Now, before I put this 301 motor back together, I just want to remind you that if you took out the bearing, when you drop it back in there, you want to be sure that that little slot on the side of the bearing lines up with the silver lube tube. Okay, so you drop the bearing in there and you can line it up before you put the bearing retainer in. That way, if you do add oil or motor lube, it'll be lined up with that slot just like they did it at the factory. Okay, and this goes a little bit quicker, you'll see, than when I do the 401, because we're not fiddling with these wire springs and stuff. But we want to put our little metal clip in here, and I put it on the plastic side and just put the base down, and then we'll put our pin insulator in, those little tabs if you have them facing into the motor to cover the where the wires come up. Very easy, right? And then we're going to set the top housing of the motor down on there with the pin brace. Matter of fact, let me add some lighting here. That looks a little brighter. So with this pin brace part to cover the pins, we're just going to gently drop that top housing with the motor shaft and everything right down in there. And we want it to line up with the bushing. Make sure nothing is blocking it here. Does it feel like it's lining up with that bushing? So I'm going to pull it out and look down in there. And now the bushing really looks straight. It looks right, properly centered in the hole and facing straight up. Got this. Got our clip. Let's try it again here. There we go. So holding the two pieces together, I'll just look all around to make sure the seams where the two pieces meet are flush with each other, and they are. So I'll start by putting one of the hex nuts in there behind the silver tube, and one of the long nuts, one of the long nuts in the correct place to tighten those two together. Now you don't have to tighten these real hard. Remember, this is Bakelite. You know, it's a plastic and it's old now. So just so that they're snug, because it's aluminum and it will expand and contract a little bit as the motor heats up and cools. We'll put the other hex nut in there. Okay. And sometimes to get the screw started, it's good if you just put your finger on the end of that hex nut. It shouldn't really spin because it is a hex nut, but pushing on it can just kind of like push it out the back end there, and the screw won't get started in the thread. Okay. Now we'll just spin it. Just give it a spin here and make sure it sounds good. Okay, now we're going to get down here to the motor brushes and the brush covers. Okay, to put our brushes back in, we'll just make sure that our little wire is in place. This bent spring that has the wire soldered back here from the coils, that's what's going to hold the brush and the brush holder in place. So when we put the brush in first, you'll see the wear pattern. It's curved, and just like if this was the commutator, you want the curve to match the commutator inside. You don't want it to oppose. So with that in mind, you'll see the slight curve there. We'll rest it in place there. Then we're going to take the brush holder, and you see how the one side has an open slot. And that's so you can look in there and see how much of your brush is left in the future. And we'll just slide that onto the spring and slide it. Oh, sorry. I'm going to take it off of that slippery towel maybe. So let me get this back in here. I just wanted to rest my finger on that spring wire there so that it wouldn't push out when I pushed in the brush holder. So with the slot facing up, we'll slide it on there. We'll gently work it behind the spring and keep sliding it forward. And the idea is that we're going to slide it onto the motor brush and over the motor brush. Yep, and if you have to, oh, I see the brush is turned just a little. The brush is twisted just a little. So we'll wiggle that to get it on the brush. There we go. Get it flat, and then we'll just push it in with our thumb. Now, this end of the holder has to go in far enough that the brush cover can sit up against it here. Okay? But the one thing you want to be sure of is that the front of the brush holder does not touch the copper commutator. That's bad. Okay? So we just get this in far enough that we'll be able to get the brush cover on. See if I can remember the best way to do this. Maybe I'll turn it like that, maybe. I always do the one with the silver tube first because you got to manipulate it, the brush cover around that tube a little bit. Both the brush covers are the same. There we go. It's a tight fit right there. See that? Okay. And this is fitting flush, so I know my brush holder was pushed in far enough, but it was not touching the copper commutator. So I'm good there. Because if that brass holder touches the copper, it's going to really damage the copper commutator, which pretty much ruins the motor. So I'm just going to listen carefully and turn the motor up here so I can quiet as a church mouse, as my grandpa used to say. So I don't hear any metal on metal scraping. Let's get this one here. Make sure my little spring is in place there. Right? And make sure I've got the curve correct. You know what? I think I'm going to slide this into the brush holder a little bit on this one, because I'm kind of holding the motor at an angle, and I've got to turn the brush holder so the slot is up. Let me check that my curve, yep, my curve is going to match the commutator. My open slot is up. I'll slide it into that spring that's going to hold it. Yeah, it slipped around a little. It slipped actually off of the brush. There we go. Nope. I'm trying to do this behind the camera, and I'm sorry. I'm having a hard time. I am rusty. I just think I'm rusty. Haven't made many movies for a while. All right. So what I did was I got the holder onto the brush at an angle and then pushed the holder down next to the spring. Okay, now I'm going to slide it forward to make sure it clears the cover, but when I look in here I can see that the brass is not touching the copper, and that's perfect. I can turn it if I want. Very quiet. We'll go ahead and put the other brush cover on and the final screw. Same thing with this brush cover screw. We just want to snug it up, you know, so that it's holding the brush cover. We don't need to bear down on it in any way. There's no weight or anything that it's holding. Okay, so I'm going to get my equipment out here and hook up, and we're going to run this motor and just see how it sounds. Okay, so I just have a light dimmer switch in a gang box here, and I spliced on some tubes connections from a broken terminal on an old Slant-O-Matic that a guy was parting out, and the wire terminal was cracked anyway, so I asked them for the wires, and we'll just run this up now. And well, you really feel the fan blowing air out of here on this side. It's funny, this is vented only to the hand wheel side. Okay, nice motor, nice motor. So that's the 301. I wanted to show you the difference in that, and put that aside, and then that's going to bring me back to the 401. So I'll gather up all the parts of that, and those of you interested can see the 401A assembly, where we have to route these wires and pin connectors and everything back into the machine, into the motor. And then after we assemble it, we can do our noise and temperature testing. You know what? I forgot. I'm still soaking this bearing in oil. So I think it's getting a little late. I think I'm just going to let that soak overnight, and tomorrow is another day, and then I'll pull it out of there and wipe it off, and we'll hope it's soaked up a lot of that nice new oil. Then we'll assemble the 401A and do the testing. Okay, so we'll see you tomorrow. Okay, it's already tomorrow. So this has been soaking in there for hours and hours overnight. The bearing soaking in just plain Singer motor oil. Let me pour off the excess oil here. Put that aside. Let's take a look at this. Yeah, oops. It's very oily, isn't it? That's what we'd expect. So I'm just going to wipe off the excess a little bit and swab out the inside. Not much in there. I'm going to put this just on this old oil rag here and put it aside now. And I'm going to start reassembling that motor real quick for those of you that want to see a 401 go back together. What was interesting to me was this oil got discolored. I don't know how well you'll be able to tell, but it has like a greenish tint to it now. And I've had Singer oil, did I call it motor oil? I've had Singer sewing machine oil sit out for days in cups like this, and I've never seen it turn a little bit green like that. So I don't know if it soaking into that bearing it forced out some more old stuff or not. I don't know. But let's see about getting this back together now, because on this one I pulled it apart and we pulled out all the retention clips and the contact pins and everything. Right, so I think I'm going to maybe start with that first. And when you put these back, these little contact retaining pins, one has to come into each space on each side of the lower bearing. And then these two pins have to line up with the holes to come through. But these are the two that kind of give you a little trouble. Well, one came through pretty quickly. Let's see, I don't see the other one. I'll use the other end of a Carolyn Rogers Q-tip extension from the bicycle spoke, because it's got like a little hook on the end. I'll see if I can gently pull that out. You don't want to force this. I've had that little connector piece break off the wire before, and I had to solder it back on, and that was a real delicate job for me. See if I can realign this again. And so you want to be patient when you're working to get these out. Don't force them. Don't pull on the metal piece. It's better if you can grip back on the wire and get those. Okay, so I've got those two in position now, so I'll be able to put those in the right place. The pins go through the back of the holes here, and you have to dress the wiring through these slots right below, just like I did with the 301. Okay? And you don't want any wires to get pinched between the winding housing here and the base of the motor. And again, it's better to finesse these little parts than try and force them, you know. Like I thought I had it, but I think the pin was a little crooked and I didn't want to force it in, because these are soldered also. So better to take an extra minute and work them through than to have to get out the soldering iron and clean that pin and set everything up and try and solder that little tiny wire. I think I must have it twisted because there's a little C shape around the solder, so that must be hitting something down in there. There we go. Okay, wires dressed through there. Let's go back here and make sure I still have my contacts coming out. Set that up better. I'll take my wedge and stick it in between the winding housing and the Bakelite motor base. And then this insulator, like the 301, had little tabs to cover those wire slots. The 401A model year and after that did not. It just had this kind of stiff fiber board or cardboard. That looks good. So I'm at the point. Well, I guess I could have put the bearing back in there before I did this. I was so excited to get this motor back together. Can you get a good look at that groove? Okay, and I think when I get this in here, I'm going to want the groove to point out towards one of the sides where the brush covers are, in case I ever want to just open that brush cover and put a couple drops of oil on there. So I'm going to just go ahead and drop this in here. Try and line up the slot, I think, with this side where the pins are, because this would be up when you lay the motor down, and I see my slot is right there. I did good on that. So if I can keep it in that vicinity, if I ever want to access it in the future, it's going to be very easy. Now I've got my bearing retainer here. See if I can get that in there. And like I just said, it would have been smarter of me to put that bearing in before I did this. It wasn't very smart of me. But as I showed you on the 301, you don't necessarily have to separate these two pieces to clean or remove the bearing and the retainer. I think I've got it lined up, ready to go. I'm getting to be an old pro at this. Make sure I get down in here. See if I can turn it. I heard a little snick. And yes, I see that it's in place in there. Okay, so no harm done by doing it after putting this in. I'll get my wedge piece back in there, and I'll put my insulator back in there. And let's take the top half of the motor now, and since this one does come with the insulator piece, I'm going to gently put it back in there and slide it up into that aluminum housing. It looks great. So since my pins are up here, I'm going to put the back support for the pin system on top of it. I don't want to put that in opposite because it won't work. Now I'm going to see if I can line up these parts. Oh, what did I just hear? I just heard the little yeah, I think I when I pulled it up a little to straighten it, the wedge fell out. Pretty typical. These two little pieces give you a little bit more problem than the rest of the machine. Let me make sure. Oh, did it again. Okay. And we'll see if I can get this in here and line it up. What you're doing here is you're lining up that motor shaft with the bearing down there. And once it's in there and it's seated, you want to go around and check all the seams between the upper and the lower motor housing. Okay, and that looks good. So we're going to hold these pieces together now. See, I kind of pinch them like this, and I want to put my hex nut in here on the brush side. Okay, then I'm going to turn it, put my finger on that hex nut, still squeezing the two parts together, and put one of the connecting screws between the two parts of the motor housing. As stated on with the 301 motor, you want these to be snug, but by no means bear down on them. Do not do that. I'll put the other hex nut in. Yeah, looks good. I'll brace that hex nut while I put the other long screw in. There we go. Oh, I wonder if that groove in my bearing is still going to be accessible. I got this together now. I can look at that. What I'm looking for is right down in here. I can see the bearing retainer. I see the bearing under it, and I see the groove is right there. Okay, the two parts are completely and evenly together now. So I'm going to work first on these little retaining clips where they tuck in to a groove in the bakelite, kind of curling around the hex nut for the brush cover screw. Yeah, there we go. Just like that. And then I'm going to get one of the motor brushes and check the wear curve against that curve, and I can slide that in next to that spring. Hold it for a second. Get my brush holder with the open slot facing up, slide that over the brush spring, and push that up. Come on, you. Push that up. Whoa. I know I've said stuff like this before, but you won't have this problem because you won't be working behind the camera on it. So we'll do it again. I'll get the retaining clip in there. Here's another way I can do it too. I can slide the holder onto the spring and get the brush in there like this. Slide the brush in with the curve, wear curve matching, and now get that brush holder past the edge of that retaining spring. Doesn't quite want to sneak by there. There we go. And I'll, I shouldn't have let it go. I was just going to point something out to you. Get the brush holder started up over the brush. That's what I wanted to do. Okay. Then, keeping it pressed down a little, I'm going to slide the brush holder in till it's flush, right about there, so my cap can go over. But I want to be sure that the holder's not touching the copper commutator. That's very bad if that happens. Metal on metal will just destroy the commutator, and all this work on the motor will be for nothing because the motor will be ruined. Let's get the other side in here. Same thing. See, this one I'll try lining the brush up first and then sliding the holder up over it past the retaining spring. Up over the motor brush and sliding it in till it's flush. And one way to be sure that you've got this in far enough is just take your brush cover part and put it on there and press it in to where it's all a smooth fit. Then you know this is in far enough but not too far. Okay, let me check it on the other side. Yeah, they were both sticking out just a little bit, both the holders. I'm so hesitant about jamming them into the commutator. So what do you think of that? We're at the point now where I'm going to again do the noise and the heat test after I've charged up that bearing with fresh oil, and we'll see how it compares, if it made it any better, if it didn't, or if it made it worse. Let's check the cold temperature before running the motor. We'll get an idea now. Before I worked on the motor, it was 80.6, and that's about the temperature of the room under all the lights here. Speaking of which, let me turn on one more. Okay, so let's see what we get this time. I can get right down close to that bearing. 82.8. Okay, so that's going to be our baseline before running the motor. We'll hook up power to the motor, and then we're going to run it a while, and we'll take some more temperatures here. Was 86 plus. Okay, we're going to let it sit for a little bit and we'll see the temperature without the fan running here. When I did this the first time, I was hitting up about 97. So I'm going to let this motor sit just for a minute, so the temperature should build like before. After I shut off the motor, it rose up to about 101 because there's no motor fan blowing to cool things down. So while I'm doing that, I just wanted to mention about the bearing. Just a reminder here. What I did was kind of extreme. You know, I took the bearing out of here and I soaked it in alcohol and I washed it with a crud cutter cleaner and degreaser and so forth. So I was really trying to get it dried. Well, I was trying to get the oil out of it, I guess is what I want to say. And then I heated it up and soaked it in a cup of oil overnight, wiped it off and put it back in the motor and put the motor back together, and we're testing here. Let's see what this temperature is now. Just under 95. For me, I'm interested to do the noise reading now, but so far the temperatures, running temperature of the motor is a lot less after getting some fresh oil. Okay, let's get on here. Now I had it setting about here, this position before. See the ambient noise when I talk and when I don't. It's about the same. Let's go ahead and run it up. Okay, now before the noise was averaging about 79 from looking at my notes, and it's running just about the same there now, 78 or 79. So and both times that was with the brush covers off and just having the motor you know, supported but sitting there. I am kind of curious how it is if the motor's in the upright position, where this is how it runs in the motor. It sits upright in the motor. Let me get this going. Hold it down here near to the bearing, I guess. does tend to run quieter when it's in the operating position, how it sits in the motor. So that's good. But when I tested it in the same position as the first time, the noise was still about the same, maybe a decibel less or so. So the biggest improvement that I saw was in the heat, which is good. It's good for the life of the motor too. So I was really, to be honest, I was expecting that there was going to be more of a difference of noise. But we'll see. We'll take what we can get, right? And just as a reminder about John Russo's talking about this, putting, you know, you don't even have to take it out of the housing if you open the motor. Just take oil on a Q-tip and kind of clean it out of anything and get some oil on there, and if you feel there's too much oil, just wipe up the excess, and then that oil should soak into the bearing. And then Carol Magnuson's, when she had her growly motor, she just took opened up the brush cover. I think she may have even left the motor in the machine, but she could see the little groove in the bearing. She could see that groove that's in there, and she just got toothpick and got oil on the tip, and so she could just pinpoint it right into that groove and put a couple, 3 little drops of oil into that groove, and then she ran the motor and said it was quiet, that the growling that she'd been working on was gone. So there's a long-time viewer's personal experience with her 404 motor and adding some oil down into that bearing. So I guess that's going to conclude the video, showing you, if you've never seen it, how to open up these motors and take them apart a little bit, how to get the bearing out. I really like John's idea of using this round dowel. My twist stick was effective. It's just if it was easier to have it slip and slide off of the brush retainer, where this can't, even if this just keeps turning, but it makes contact with the brush retainer. And you saw me use a pencil eraser, and you saw me use a paint stirring stick, you know. But the main thing is just to understand you have to depress that bearing retainer flat and turn it counterclockwise to get it out of the clip. And then you reverse that when you reinstall the bearing. And a reminder that when you put the bearing back in, you want to take wood or plastic and put it into the bearing and move it a little bit so that it's centered and the hole is straight up. I had a couple times doing this where the bearing looked good, but when I was putting the motor shaft back into the bearing, I was struggling getting it in there. And I'd take a closer look and see that this was just barely tilted one way or the other. So I would re-straighten it as best I could, putting the stick down in there, and then the motor shaft would slip in. It's a very tight fit for the shaft. And looking at it, if I was doing it again, I might put a drop of oil on my fingertip and just wipe that motor shaft a little bit, just to help it slide into the bearing during reassembly. It might help a little bit. And for all of you who noticed how dirty the commutators were on these motors, I know that too, but this video series here was more about working on the bearing and learning about sintered bronze bearings, and you know, that they should use oil, not grease, and preferably plain sewing machine oil without additives. And I will put at the end of the video, I'm going to put a slide of John Russo's American Sewing Machine Restoration, his business card again, for those who may be interested in contacting him. He also does 1950s and 60s other home, like he's shown me some pictures of a vise he's restored, and he has some old tools like what's that kind of circular saws and stuff like that, and they're heavy duty just the way these Singer machines were at the time. And he hopes to retire next year, and he'll be going more and more time with his business. But if you have questions that I didn't answer or bring up about these bearings, or sintered metal, or powdered metal like that, I'm sure that he could find the time to answer them for you. He's a very nice gentleman. Thanks so much for tuning in. I'm sorry my videography and presentation skills are a little rusty. I haven't been doing near as many videos, where I used to do you know, a couple a week. I'm lucky if I get a couple a month now. But I enjoyed doing it, and thank you so much for watching, and I hope you keep an eye out for something new on my channel. Take care now.